Alright, so in this video we are going to discuss a super important question of chemical kinetics. It was asked in IIT-JAM and it's a very good question. It's a very beautiful question because a lot of concepts has been asked in a single question, right? So eventually this questions become a super important question, right? So without the further ado, let us begin with our question, right? So for the first order reaction, right? So for the first order reaction, the order of the reaction is clearly mentioned here. That is, it's a further first order reaction, right? So this is the order of the reaction, right? So these were the four options given for this question, and this is a MSQ kind of a question, right? So more than one options could be a right answer, right? So let's see how we need to apply our approach in order to solve this type of questions. Okay, so let's consider the options one by one, right? So let's read out the first option. The concentration of the reactant decreases exponentially with time. So which two terms the question is relating? Your concentration of reactant and your time, right? So we have to analyze these two terms, that is your concentration of reactant and time. So, is there any formula for first order reactions which relates your concentration of reactant with time? So, so immediately your mind should give you an answer that yes, there is a formula which relates your concentration of reactant with time, and here it is. This is your formula, right? For first order reaction, this is your formula which relates your concentration of reactant with time, right? So, just we need to correlate these two formulas, right? So, the question has asked that with increasing time, what is the relation on your concentration of reactant, right? So with increasing time, right, if we increase the time, so if we increase the time is clearly visible here. If we increase the time, this kt term would also increase, right? But this e to the power minus kt term would decrease, right? Because it's a negative exponential term, so this value would decrease and this whole value will also decrease, right? So eventually your value of a is decreasing, right? So with increasing your time, the value of your a, that is your concentration of reactant, is decreases, right? So let's see what does the option is saying, right? Is it saying the same thing? The concentration of the reactant decreases exponentially with time. Yeah, so it is the thing we have solved right now. So this option is absolutely correct, no doubt in this, right? So now let's move on to our second option. So let's see what the option is saying. The half life of the reaction decreases with increasing temperature. So which two quantities this option is relating, right? So this option is relating your half life of the reaction, right, with increasing temperature. So we have to correlate your half life of the reaction with increasing temperature, right? So let's see. Okay, so is there any formula which relates your half-life of the reaction with temperature? So there is we know that there is no such formula which relates your half-life of the reaction with temperature, but this there are two formulas, right, which indirectly relates your both the terms, and you can find the relation between them using these two terms, right? So we increase the temperature, as it's mentioned, we have to increase the temperature in the question. So if we increase the temperatures, wait again, temperature is represented by your capital T, right? You don't have to do this mistake, right? Small t is for your time and capital T is for your temperature, right? So if we increase the temperature, right? If we increase the temperature, it is written here that k rate constant increases with temperature. So it's a well-known fact in chemical kinetics that your rate constant k does increase with your temperature, right? So with increase in temperature, your k value is increased, right? Your k value is increased, right? That is your constant value is increased. And if this k value is increased, right, so t half will decrease because there's like inversely proportional to each other, right? So with increase in your temperature, your k, that is your rate constant, increases, but your half life, that is your t half life, decreases. So now let's see the option, right? So it is saying the half life of the reaction decreases with increasing temperature, and this is now we have solved here that it is with increasing temperature the half life of the reaction decreases, right? So this option is also correct. This option is absolutely correct. Now, right now, let's see the third option, right? Let's see the third option. Okay. So yeah, it the half life of the reaction depends on the initial concentration of reactant. Now this is a very well known fact, right? Whenever we study chemical kinetics for first order reaction, the teacher taught us that the your concern that the concept taught us that your half-life for the first order reaction doesn't depend on the initial concentration of the reactant, right? So half-life of the first order reaction has nothing to do with your initial concentration of the reactant, so it is independent of the initial concentration of the reactant. So clearly this C point, that is your C option, is incorrect option. So C option is your incorrect option, right? Now let's see a D option, right? The reaction proceeds of 99.6% completion in 8 half-life duration. Now this is a trickier option among these all the three options, because you have to solve this question, right? You literally have to pick up your pen and a paper to solve this option, right? In other three options, it's possible that without solving it on paper, you can still do the you can still find the answers for these three options, because it's purely conceptual topic. But you have to solve this fourth option using mathematical calculations in order to get to the correct answer, right? And believe me, never act smartly, right? In this type of questions where mathematics is involved, never do it orally, right? It's from a personal experience that never do the mathematical calculations orally if you are a pro in this, but still you don't have to do it, okay? You have to calculate it through pen and paper, right? Okay, so now let's see the D option, right? So this is the basic formula, right? This is the basic formula which is used for first order reaction when the time period is given in terms of your half-life, right? So let me write over here that this is applicable for only first order reaction. It's a very important point, right? You uh, should not account this formula for rest of the orders. It's only for your first order reaction, right? Now there are certain aspects here, right? First is I told you right now that it's valid only for first order reaction, right? Second point over here is, right, this formula is only applicable when your given time, that is your given time, is multiple of, right, it's multiple of your n, right? When it's multiple of n, then only you can apply this formula. And for this particular question, it's clearly mentioned that the time period is your eighth half-life, so it's obviously a multiple of your n, right? So if we solve this question, so this is the fraction of reactant left after n half-lives. Now what happens is, after n half-lives, the amount of reactant left, right? So this formula accounts for that, right? So let's suppose the amount of reactant left after n half-life is x, right? So x equals to, and we have assumed that the initial concentration of a reactant is 1. We are just assuming, because it's not, because no such value is given in our question, so we have to assume in order to get to the conclusions, right? So we are assuming that a naught value is here 1, right? So x equals to 1 by 2 to the power n. N is 8 here because it's clearly mentioned in the questions that we have to calculate, right? You can see we have to calculate for 8 half-life duration, right? So n here for is 8, right? Because it's a multiple of your half-life, okay? Or it should be it's possible that they should give you a number also. If it's a multiple of your half-life, then you surely can apply this formula, right? So if 8 equals, right, x equals to 1 by 2 to the power 8, so this would give some value around 0.0039, right? Okay, 0.0039. So this 0.0039 denotes, or it's tell you value that this much amount of your reactant is still left in the reaction mixture after 8 half-lives, right? So we have to calculate how much amount of reactant is reacted in 8 half-life durations, right? So if your initial concentration of reactant is 1, right, we have assumed it here that the initial concentration of reactant is 1. So if we minus the unreacted amount, right, the amount which is still left from this initial concentration, we would get the value of amount which is reacted. It's simple mathematics, no doubt in this. We would get the value of amount which is reacted, so it would come around 0 point, somewhere around 0.996, right? Please bear with my handwriting. Actually, I don't have any equipment to write, so I'm just using my mouse, so that's why it's coming so haphazardly, right? Okay, fine. So this is the concentration of your reactant, that this concentration, or you can say this much amount of your reactant has reacted with your has reacted in your reaction mixture in 8 half-lives, right? So we have to find how much percentage of reactant is reacted, right? So this is the value of your reactant. We have to find this, how much percentage is this of 1, right? So if we'll multiply it by 100, and divided by initial concentration, it's 1. That's why I took 1 as a value, because so that your calculation would get easier, right? So it would come, the value would come somewhere around 99.6%, right? So 99.6, right? So the value has come to be 99.6%, right? That is 99.6% of your reactant is already reacted with your reaction mixture, right? So let's see what's the option is saying. The option is saying your the reaction proceeds of 99.6% completion in 8 half-life duration, right? So this option is also correct, right? So what we concluded, that option A is correct, option B is correct, and option D is correct, right? So the answers for this particular question is option A, that is option B, option A, B, and D, right? So it's not a trickier question, it's a simpler one, but just you have to be